taken trying to talk about the history of climate change and climate science as a huge subject. So I thought that, given the context of the festival, that I should try and take it through from the perspective of communication and miscommunication, and it touches on many of the issues that the previous panel have talked about, which is the role of the scientist expert in universities, which have largely been focused on kind of producing scientific knowledge and kind of sending it out there. And now the challenges of a public and politicians and things like that suddenly need information from scientists, and how we adjust to that. So that's a thread that sits beneath my talk. I'm going to call it the climate wars, and you'll see why in a minute, because what we're really looking at here is essentially a battleground of information that's coming from all sides about this. And this happens to be about climate change, but it could be pandemics, it could be anything of real critical contested interest to science and to the public. So I'm based now at the Royal Scientific Society in Jordan. I'm a research chair in sustainability there, but I'm also a professor of geoscience communication at the University of Plymouth in the UK, and I have this role as co-director of the 3CS Climate Change Sustainability Research Centre at Ashoka University. And in each of those areas, the key thing is really about how do we communicate technical, complex science to non-technical audiences. And that could be media, that could be communities, that could be politicians. So anyway, so can you hear me okay? Can you still see me?
Yeah.
Perfect, sorry. So about over 10 years ago, I made a documentary for BBC Science called Climate Wars. It was the history of climate science, and in many respects, that was over kind of 3 hours of television, really tracking it from the 50s and 60s all the way through to the kind of present day and the emergence of a kind of modern understanding, collective understanding of science. So if you're interested, you can go and check that out on YouTube and things like that. But I just want to draw attention to a few key points that emerges from that. Now, let me just give you a little clip, a few minutes you get a sense of this here. So hopefully this will work. And actually, I wonder if I should, if you don't hear the sound properly, I can share this better, but let's see if this goes.
All of that structure.
Global warming is not a crisis. I think this conference proved that there's no consensus.
CO2 is in no way connected to global warming.
Yeah.
It never has driven temperature. It never will.
School children across the world are being scared to death based on speculative, unproven computer models, and a lot of people, including the media, should be ashamed of themselves.
Some of the scientists here have spent years questioning catastrophic global warming, like climatologist Pat Michaels.
You seem to really thrive on the energy of the debate of this.
Oh, sure. I kind of picked this was going to happen somewhere around 1972, which, I date myself. Said Woody Allen.
Now, have you lost friends over this, for example, or has it got to that level?
No, I don't think anybody should go into science to make friends.
The carbon dioxide is not a pollutant.
Are you saying that we're now at a climate altar? I do not know of a single scientist who accepts the fact that there's been any increase due to global warming.
Some see these people as heroes, as modern-day Galileos speaking out against oppressive orthodoxy. Others compare them to Holocaust deniers. That is one hell of a difference of opinion.
So one of the key things really that particular program was looking at was where the science starts to get contested. Now, this graph here, you probably are aware of if you've looked at any climate change. This is what's called the Keeling curve. This is the measured record of carbon dioxide on the planet as measured from Mauna Loa in Hawaii. And what we see is it starts the late 1950s. And even from the start, you see the rise and fall, which is the annual breathing of the planet between the northern and southern hemispheres. And then what you see is a rising incline of carbon dioxide levels. And what's interesting is we've had that record for all this time. And it always surprises people of when it is that the first time President of the United States talks about climate change as a key issue. The burning of fossil fuels is affecting climate change. And I'll make your own, you can make your own decide about where you think that is going to be. But the answer is 1965. In 1965, Lyndon Johnson says this generation has altered the composition of the atmosphere on a global scale through a steady increase in carbon dioxide from the burning of fossil fuels. Now, I was born in 64, so that means for my entire life, we have understood at the highest political level that the burning of fossil fuels drives climate change. And yet, why is it that we are now essentially, 50, 60 years further on, and we're still having debates in many areas, particularly parts of the world, about the role of this? What we see is that when we get to the 1980s, there is a number of reports under the President Carter's line, that talk about trying to model the climate change and improve the science. A report in 1978 by the so-called Jason Committee, and then a report in 79 by the Charney report. These are all expert science panels that basically talk about that, the carbon dioxide increases is driving climate change in a significant way. The big change that happens is in 1980 when Ronald Reagan comes in, and Ronald Reagan brings on a guy called Bill Nierenberg, and Bill Nierenberg is the head of Scripps Oceanography Institute in San Diego. Very, very well-respected climate scientist himself, and indeed the person who had basically supported Dave Keeling in getting his measurements of the CO2 off and running and continuing. And he was put in charge of a project, of a report that brought the climate scientists together, but interestingly enough, also brought together some economists. And it was the economists that framed the climate science as, yes, it's happening, we accept it, it's real, but framed it in a slightly different way. One of the ways was, hey, maybe it's not so bad. Maybe this carbon dioxide is good for plants, isn't it? So maybe it will actually help us increase the wheat fields of the earth. Maybe we can feed more people as a result of this warming climate. That was one angle. A different angle was the role of, well, actually, maybe this is bad, but maybe this is just what humans need. This is our moonshot. This is our fundamental challenge. It's going to have scientists rising up and with human ingenuity getting through this. And so on the back of that, then, really two different approaches spun out of that. An approach that followed science and was characterized by the start of late 1980s of the International Governmental Panel on Climate Change, which is a global kind of association, collective of scientists, climate experts that publish on climate science, write review reports, which then get fed through the political system, have a transparent review process whereby anyone can sign up to be a reviewer and can evaluate it and produce reports that are signed off by governments and signed up to by governments. But then there's another thing. There's an alternative, a non-governmental international panel on climate change. This was created by a group of skeptics, of people who were contrarians, arguing against the science, led by a guy who you saw in the video there called Fred Singer, who was the head of at one point, the American Meteorological Society. So he was a weatherman, if you like, a meteorologist. And indeed, several of the people you see listed there are meteorologists. But many of them are not, and many of them have got no particular association with climate or with meteorology. And indeed, some, and there's a particular one, Richard Courtney in the bottom on the left there, who is editor of Coal International, or was at that time. And other people, a guy called Christopher Monckton from the UK, is a very prominent skeptic with absolutely no scientific or environmental credentials at all. In fact, if you look at that whole list, none of those people have published on climate change, climate science. So one of the interesting things I think is, for me, was the contrarians who were scientists, who were meteorologists. This Fred Singer here, Pat Michaels, you saw in that video, and Richard Lindzen at MIT there are very prominent people who were arguing that this new thing of climate science was really contrary to the fundamentals of meteorology, of the weather forecasting. I think what that reflects is kind of battleground between two sciences, the established science of meteorology, where the complexity of the short-term weather and the long-term averaging out of climate that the climate scientists were developing. And with that in mind, I love this little video. I'm just going to show this video, but it tries to set out the differences. Let me show you this.
Well, whatever happened to global warming, eh?
Mm-hmm.
Stop. From October the 1st, if you say whatever happened to global warming, eh, whenever it's a bit cold or wet, you could be cooling off in a prison cell. This leaflet is being sent to every household in Britain. You have until September the 30th.
It illustrates a rather humorous approach to this fundamental difference between weather and climate, which confuses the public and indeed in some cases confuses the politicians. So the other area of great contrarians that has happened and held climate science back is actually the geologists. And I'm a geologist, and geologists have been very particularly important part of the push up against climate change policy, climate action. And this one's characterized by this guy called Iain Plimer, who's one of the leading geologists, Australian geologists and economic geologists. So he works on mineral resource exploitation, extraction. And his point is, if we can't understand the changes, the climate changes of the past, and climate has changed very dramatically in the past, then we can't hope to understand the changes that are happening right now. So it's kind of playing on the unfamiliarity of the past geological changes of mountains building and oceans opening and closing and huge volcanic eruptions and all the rest of it, to say, look, actually, we've got no idea really, what's happening with this. So that becomes an important area. But actually, one of the most compelling aspects now of the climate science debate really is the geoscience and the geological record. And this is an extraordinary graph, really. This is the measurement of the CO2 concentrations from ice cores from the Antarctic largely. The record goes back almost 1 million years, 800,000 years. And what we see is the ups and downs of the ice age cycles in and out of ice age between about 180 parts per million when we're in an ice age and 280 parts per million when we're out of one in a so-called interglacial period. And we see the planet bouncing between these 180 and 280 for about, the last million years over the course of hominid and human evolution, really. Modern humans arrive about 200,000 years ago. And we see that as we come out the last ice age, a fundamental difference it gets to about 1900. And instead of it going back down again, it goes on and on and on and on, jumping by about another 150 parts per million. So way more than what has been bounced around between in and out of the ice ages. And that is the human legacy. So what I want to just focus on in this last little bit then is, why is it that people are uncertain about this? Is it indeed about these contrarians that are confusing the issues and blurring the science, or is it something else? And there's certainly an element of manufactured uncertainty. There's a really nice film by Naomi Oreskes. It's called Merchants of Doubt, and she's got a book on this, where she highlights the role of the tobacco industry and the big pharma industry kind of approaches of seeding doubt. You see the quote there, seeding doubt is the best means of competing with the body of fact. It's much easier to just make people think, well, maybe it's not that, and then a whole bunch of things can take over. So creating doubt is an important part. And indeed, it's a very simple thing to do, to the so-called idea of junk science. We see it in pandemics, we see it in other things as well. But in terms of climate change, there's 3 steps. Number one, argue that cause and effect have not been established in any way. So again, this goes back to the tobacco industry fighting against regulation and big pharma as well. Say there's no clear indication that this particular thing causes this particular effect. Then statisticians and baselines come up and find it has. And then they say, well, statistics can't prove anything. That's not the answer. But of course, the statistics over time get better and better and better. And eventually what the beautiful third one is to say more research is needed. Let's give these scientists more money, more research, so they can prove absolutely that this is the case. And of course, that misses a fundamental understanding of what science is about. It's not about proving anything. If it's anything, it's about disproving, but it's about always asking and always questioning. And so politicians have used this then. This was Frank Luntz, George Bush's one of Republican advisors, really, in 2003, arguing to the Republican Party that the way you do this is that you highlight scientific uncertainty. And as soon as you highlight scientific uncertainty, people feel easier to just reject the science because it's too complicated for them to understand. But I would argue that that is a relatively small part of the way that the reason that people aren't necessarily conforming to the way the scientists think about these things, the vast majority of the scientists. Because what we see, this is our famous plot showing the so-called 6 Americas, how the public see climate change. And there's basically 6 different publics there based on their values, the way they see things, their political views, their environmental views. So there's a small amount that are alarmed on one side, and there's a small amount that are dismissive on the other side, and then there's groups in the middle that are different levels of confusion around this. And so the point here is that, it's how we get our information out that's actually going to be to these different publics that's critical. And I think scientists here have been really lazy in the way that they've done it. They write their reports, they publish it, they put it out there, and they don't think about trying to reach different audiences. And one of the reasons for that in climate change is because it's just so complicated. This is actually a quote from a climate skeptic, but I think it's absolutely right. Global warming is a complicated, topic, sprawls in 1,000 directions. There's no one really that's an expert on all aspects of it. But what this quote opens up the opportunity for is basically to say, well, if no one is an expert on it, then anyone can have a view on it. And of course, that's not necessarily the same thing. So other aspects is politics. This is from the US, but the way that people see environmental issues and the way they see particularly global heating, climate change is very much dominated by their politics. So Liberal Democrats, for example, largely 80 to 95% supporting idea that they're very worried or somewhat worried by climate change. And right down at the bottom, 14% are the conservative Republicans. So, and that's something that goes all the way through science, all the way through graduates in university, etc. And it's an important filter. Interestingly enough, what the previous one that I showed with the 6 Americas was based in 2010, 2011. This is what it is now. And so now we have a relatively, a much bigger, about a third of the population in the US being alarmed about climate change, and 26 being concerned. So that's over 50%, the majority in those 2 categories. And we still have a residual 10% that are dismissing it as a load of rubbish. But I think what we're seeing there is a gradual coming together of a consensus among the public that actually, this is happening. And I wonder, it's interesting, what has done that? The science hasn't changed since 1965, more or less, What has changed? And I think one thing that's changed is a much wider collective of public that's actually engaging in the climate debate. So the top left images of the Paris Climate Agreement, where the politicians of all the Christiana Figueres and colleagues that pushed through the Paris Climate Agreement. So, but also supporting that were religious leaders. So we see Pope John Paul, who wrote his encyclical about climate change. In the bottom right, we have Elon Musk. We have business leaders talking about climate change affecting the business bottom line. And we have people like Leonardo DiCaprio, celebrities, media influencers that are talking about it. So really the difference is that these kind of groups have picked up the science and are taking it to those different groups, those different demographics, in a way that scientists never really did. And so now what we see is, I think the influencers in the climate debate are these kind of people here. Top left, local people. This is an Inuit hunter in Greenland. But local people who are actually experiencing climate change. Top right, David Attenborough, so media producers and media content that are trusted and are now starting to report and be connected. Greta, of course, so movements, social movements like the Future for Fridays for the Future, that's basically catalyzing a whole new demographic. And then street movements, protest movements of climate extinction coming through there. And so one of the interesting questions then for me is, given that these different groups are carrying forward the science, what is the role of scientists? What should we be doing at this time? Should we still be just doing our reports, or do we need to start getting much more involved in the advocacy and indeed the activism of our times? And that really relates back to some of that previous discussion we had about what universities and academic scientific institutions are for in these critical times. So I just want to finish with this slide, because here we have Christiana Figueres in the left-hand side there, and she's saying, this is a quote from earlier this year, just before COP, we're entering the most critical decade of human existence. By the end of the 20s to 2020s, we will have largely decided the quality of life on this planet for centuries to come. There has never been a more urgent need for the superpower of media companies. The time to use it is now. And then David Attenborough is talking about saving the planet is now a communication challenge. We know what to do. We just need the will. And so the point here really is that we now, as an academic scientific community, we need to really think about what our role is about communicating and how do we help bring the science to people in a way that is actually meaningful and moves the dial. So on that point, I'll stop sharing and open it up for questions.
Fantastic. Thank you so much, Professor. That was absolutely delightful to hear. And we're really buzzing. The Q&A tab is buzzing with questions, and so is our social media. And we have collected a couple of questions from here and there, and had also invited some questions beforehand. So with that, I'll get started into the Q&A section of this session. So the first question that we have for you is, what can young people, particularly those invested in STEM, do about climate change? What would your call to action be for them?
I think this has been one of the fundamental changes really in the last few years. A few years ago, the climate scientists that I talked to were thoroughly depressed. I mean, arguably, this was partly in relation to Donald Trump becoming president and taking the US out of the Paris Climate Agreement. And there was a real sense that nothing was, if the US weren't going to engage, then nothing was going to happen. But the thing that has galvanized those same people to be much more positive now is the youth movement, is Greta and this social movement. So basically what's happened is that we've created this big push, this force for change that is now pushing not just governments, universities as well. At universities, we're having to change our courses because into our universities are coming a set of people that say, we don't want to just hear about the science of the past. We want to know what we do about it. This is our future. You need to train us for this new future that's coming, not the future that you had, because really the last few years has changed all the rules, really. So I think that the youth movement is a fundamental force for change that's happening. And the main thing to do is to talk about it, is to be talking about climate change, to be normalizing the fact that climate change is real, it's happening. That's not the question. The question is, what are we going to do about it? For most people, the solutions are there. It's a case of the will to impose those solutions. And that is something that the politicians will only adapt to when they see the public is behind that.
Thank you so much. We have another question here that talks about geoscience communications. So we know that you've actively been involved in science communication, but particularly in geosciences communication, and you've been involved with the media for this. So is there any specific route to be taking towards geosciences communication? Why is it such a specialized field, and why has it sort of evolved and how has it evolved in the past few years?
It's an interesting question because science, in many aspects, the aspects of geoscience communication are exactly the same as science communication in relation to biology or physics or chemistry or whatever. But there are differences. And up until recently, science communication courses and thinking has been dominated by the big three, biology and chemistry and physics. And yet the irony is that the popular media world, hasn't reflected those big three. The kind of science that works best in television, certainly in the European area, is physics, but cosmology, the planets up there, not bench physics, not normal lasers and things like that, but actually where have we come from, those fundamental questions about cosmology. And then geology, lots of programs about geology, geoscience, volcanoes and earthquakes and dinosaurs and things like that. And then archaeology as well. And these are the historical sciences. These are the sciences that tell the fundamental human story of where we've come from. So I think that geoscience is an easier thing to communicate to people than straight physics, straight chemistry, straight biology. In fact, actually, chemistry is completely missing from the kind of popular media world. It's a very difficult thing to connect. But geoscience is great because in a way it's kind of simple, You stand there by a waterfall, and it's a waterfall. You stand there by a volcano. You stand there by a rock. We say, see how this rock, this stone, it looks like it's made of sand. We call it a sandstone. This is not difficult stuff. So people can relate to geology. The bit that's harder is their unfamiliarity of why they should even care about it. So I think but then again, this is where geoscience comes to the rescue, because we've got 4.5 billion years of amazing stories of continents moving, oceans disappearing, the most incredible things that's happening, the evolution of life, fossils, paleontology, we've got everything. So it's really a dream to be able to communicate. It's just fantastic to be able to communicate geoscience. So I would combine those two things. The fundamentals are pretty much the same, but the actual tools, the toolkit that we've got as geoscientists is probably better than any of the other sciences.
Makes a lot of sense. I mean, in terms of just geology, something that you can see.
Yeah.
It's easier to communicate.
It is. And the window for many people is the landscape. They drive around a landscape and they're often thinking, why is that there? Why is that hill there or something? So, and again, that's the thing that, say, if you're trying to communicate nanotechnology or what's happening in the middle of a stem cell, that is hard. It's really tricky.
Absolutely. And I think that plays into very well with the next question that has been put in the Q&A tab. One of the students in our audience has said that what problems of climate change are associated with chemistry and have not been tapped very well in sciences, or in media? Can you shed some light on that?
Yeah, well, chemistry is the science of all the sciences that really brought climate change out. So it was people looking at the chemistry of the atmosphere and the chemistry of the oceans changing. Roger Revelle, who was the advisor to Al Gore when he was a doctoral student, way back in the 50s and 60s. It was that kind of work that really set the basis of the climate science that we have today. I think so there are some relating to continuing that work and understanding it a little bit more. But to be honest, I think we know it well enough to not be waiting for action. When we talk about action, another aspect of chemistry I think is going to be extremely important is how do we start to pull out the CO2 from the air, and if need be from the oceans, but particularly from the air? And so this idea of carbon sequestration, drawing it out of the air and storing it somewhere, is fundamental chemistry. So particularly the storage, if it's permanent storage inside the earth, you need to bring the CO2 down, you inject it under pressure as a kind of fluid by that point, and then hopefully you try and bind it in the subsurface with rocks and permanently isolate it. And that will demand huge intelligence around the chemical reactions for those kind of changes. So, chemists have a massive role to play in climate change.
Thank you. I think the example really helped too. So that was really great. The next question that we have here is that you've been working in various countries. We saw a clipping from the USA. You've been associated with the University of Plymouth for so many years. You're now working in Jordan and are also associated with the Ashoka University. How do you think, what the first part of the question is, what has your personal takeaway been in terms of the publics of these countries percepting and understanding and analyzing climate change and its effects? and the future that climate change has on planet Earth. And the second thing is, what do you think are some major impacts that climate change has for a country like India? I mean, if you could shed some light in the Indian context, I think it will be very helpful for our audiences.
So taking the first one first, I think that one of the aspects of communication that's really critical is that we need to understand those local contexts, those local public. So, science and the understanding of science is culturally different. So only some things, you can go around communicating science, but not all of the approaches will fit those different places. So one of the key things, it actually makes it easier, because one of the first things you need to do as a communicator is to listen, to understand the public that you've got in front of you. What is it they care about? What do they want to know? And once you know that, you know what to communicate. We often start the wrong way around. This is what I know, and I'm going to tell you, and then I might listen to what you've got to say back. So as you go from India and to Jordan or into the UK, the publics are interested in different things. So that's a critical bit. In terms of India, I guess the two, there's a whole bunch. I mean, India is one of the reasons why I'm so delighted to be working in India is that the range and diversity of the issues related to climate change and sustainability is so huge. Air pollution, an obvious one, and anyone in Delhi will understand that the effect of climate change adding to the problems of biomass, agricultural burning and just the general kind of microclimate of central India. But that is a huge problem in terms of loss of life, health effects for populations. Flooding and the uncertainties over the monsoon, the Indian monsoon. Will it be weakened as a result of climate change by the ocean increases in the ocean temperature, maybe reducing the balance between land temperature and ocean temperature, which is what a big driving force of the monsoon is. But other people argue, and some of the models argue, that it could be increasing, and that means flooding. That means large-scale seasonal flooding, switching with times that are of great aridity and potential drought, etc. And then on the political front, I mean, a huge political aspect is coal, and energy. We saw at COP, India setting out the red lines particularly around coal, and we know why. Access to energy for this huge population that needs to develop, but at the same time, coal being this terrible fossil fuel for the planet. So that is a really difficult balancing act that politicians with scientists, alongside are going to have to try to resolve. So I think I'll keep it at those three. So.
Thank you so much. The next question that we have, we've got a lot of questions to cover in the next 10 minutes, but we'll just get cracking on them. Okay, so one question that we've been asked is that, can you name some achievements of countries that are signatories to the climate change conventions, and how are they actually implementing how are these treaties being implemented in countries? I mean, there's so much debate that's been going on around all of these treaties, and to see if they're actually making a difference to the at hand. So do you have any, perhaps any positive instances?
Yeah, and I think we need positive stories. I have to say, it tends to be the smaller countries that have more options to do it. Actually, in terms of regulatory change, the UK and in particular Scotland, where I'm from, has been really out in front. But we can kind of do it because we're a small country. We've got 5 million. Scotland, for example, small country, 5 million people, lots of different energy options, for example. But yet we also have an oil industry offshore that we have to kind of wean ourselves off. So there are issues there. But that is, Scotland in particular in the UK has been very strong on pushing regulatory change. And other countries like Finland and some of the smaller countries, Scandinavian countries, doing the same. The one I would pick out was Costa Rica, and it's a famous example. Costa Rica is now almost 100% of its energy is renewable. I think it is 100%. Huge emphasis on increasing and bringing back forest reforestation and biodiversity, and focusing its tourism around biodiversity, ecotourism being a major aspect. But these are small countries. These don't give you the templates for a country like India or China to do it. India and China will have to find a different way through this. But I think, as I said, it is important to hang on to those really positive stories of transformative change that make people's lives better as a result of this kind of low carbon world that we're moving towards.
I think one of the major takeaways for my conversations with you is how aware you are of the role that culture and society plays in science, and you've actively been propagating the same. In terms of countries which are really have to deal with massive populations, a large area of land, and of course various problems that accompany, do you think there are some very specific measures that have been taken by big countries such as India or China, which have worked well and which are good examples to follow?
Well, I think there is a real sense that high carbon fuels energy is on the way out. The argument is whether it's going to take 10 years, 20 years, 30 years, 40 years, etc. But for investors starting to think about big energy projects, in the short term, there may be a need to do this, but in the long term, fossil fuels are on their way out, certainly by the end of the century. And so big countries like China, for example, been this huge investor in renewable energy. Everyone points to the fact, they're bringing on, a coal-fired power station, but they're the biggest investor in renewables. The new technologies that's driving the electrification or electric vehicles, etc. Again, China leading the way on this. And it will be the galvanization, the catalyzation of the economic system that will move us into, the financial and business advantages of this new low carbon world will be the thing that carries us through. So I think that although for some people, they want to see the end of the current economic system, this capitalist system, this very consumptive system that's clearly taken us to the brink of collapse. I think that many of us still think that system tweaked to be directed more at well-being maximization than profit maximization, that well-being economy will be the way out. And the big countries will be able to shift their systems. And the developing countries are still developing their systems, so they can adjust to the well-being economy mode quicker than some of the existing the countries, developed advanced industrial nations. So I think that there is a lot of good things, but I would definitely sit around the renewable energy aspect.
One question that we've often got from our attendees is this constant problem of climate change deniers and the misinformation that's being spread. And it's all come to light even more so in the pandemic, where there's been so much misinformation and fake news going about. Now, what have you, as a scientist and a geoscientist communicator, what are some tangible actions that you have taken in your approach while dealing with climate change deniers? Are there any tips and tricks that you would want to share with our audiences that you have taken and have worked in the past?
Yeah, initially, I've had to deal with climate contrarians, climate deniers for 20 years, really. And initially, what I did was mainly try to engage in dialogue with them, and sometimes that was useful. But you quickly realize that there's different reasons for people having contrarian views. Some of them are driven by their own philosophy, and it's usually a political or an economic mindset that doesn't like low tax, liberalism, libertarianism or something. It's not really, you quickly see it's not really about the science. So explaining the science better doesn't help, because that's not why people are objecting to it. Where people actually have problems with the science, then you can have that kind of discussion. But in my view, most of the people that I encountered who were very, very strong on this weren't really interested in the science. I think this is what really shifted my thinking into trying to understand what people think and why they think it. The vast majority of people, as I tried to show in those plots, are in the messy middle. They're not fundamentally opposed. They're just confused. The science is hard. It's complicated. They know their lives are going to change. They're reluctant to change. So the science needs to be gradually and gently introduced to them and interact with them. So the most recent example, I guess, of this is I was communication lead and an evidence chair for the Scottish Climate Assembly. And that was over a period of 6 months. We took 100 normal people off the street, demographically representative of Scotland, so a mini Scotland, if you like. And over the course of 6-7 weekends, we sat them down and initially took them through about climate change and some of the implications for energy and food, etc., and gradually gave them more and more space to talk about the issues. And that's what they did. And at the end, they produce a report, write a report, having heard from lots of experts, which they then presented to the Scottish Government. And 2 weeks ago, the Scottish Government formally responded to that. And so their changes will be fed into government policy. And that was normal people that when they turned up on day one, most of them said, I have no idea what this is. And I'm not sure I care, Some of them thought it was a load of rubbish. Some of them were environmentally aware and activists, but the majority of people weren't. But all of them became engaged because the science was put to them in a way that they could understand. They could interrogate the experts. Why do you think that? Tell me about this. What about this? Have discussions. And I think we call it kind of slow cooked politics, slow deliberative processes is very effective. The problem is it takes time and resource. And often we're not willing to, as scientists, we're not willing to do it. We have to teach, we have to write a research paper, we have to get a research grant in. We can't spend 6 months just kind of holding the hands of a set of kind of publics. So I think we really need to sit down and think what's important. But I think that citizens' assembly model is a very effective one for lots of contested environmental aspects. And it could certainly run in India, I'm sure.
Thank you. Thank you so much. That makes a lot of sense. I think what I really take back from what you just mentioned is really we need to take more efforts to understand why there is so much backlash against climate change and the science that goes behind it. Why is there a reason that people are actually denying climate change when they can actually see it? So I think that's such a good takeaway. There's one question that we have that we'll just take up, and then therefore we'll go on to the last bit of our session. So there's a statement here: a major global initiative in a consortium model on renewable energy similar to the Project Genome can reduce carbon footprint in a significant manner. Could you please comment?
Oh, I don't know about that one, but I think that what we're seeing is, I guess what I would say is there's lots and lots of projects that are coming out. I mean, there's such an exciting diversity of stuff happening. And, that it's great that there's a lot of this that's coming out. That's coming through. Some of it will be technology driven, some of it will relate to behavioral change and things like that. And this goes back to that notion right at the start when I was saying about climate change has been seen as this fundamental challenge to humanity to step up and be smarter, use our ingenuity. So there's lots of these projects. But I would say that the basic point is that we already have the solutions to climate change. We know what they are. Most of them are tried and tested. But what the problem is implementing them. It's getting politicians to agree to bring this thing for this threat that is still seen as 10, 20, 30 years down the line. So technology is going to play, and science is going to play a role. But I think it's the role of scientists and technologists in influencing that implementation, of getting action. And that's where scientists need to work a lot closer with the public. So, as I say, I can't comment on that specific program. It sounds great, sounds amazing, but I think that the problem isn't going to be solved by any individual single one. It's going to be by a collective shift in thinking and in mindsets.
So much, Professor. I honestly did not realize how 45 minutes just flew by. But with that, I think we've come to the end of the session. I'd just like to ask you one question that we ask all of our speakers, and we'd love to know your thoughts on the same. What do you think is the role of public engagement platforms such as India Science Festival in building bridges between science and society? And what role is a science communication platform such as this one do? What is the good thing that it's doing to actually bring science and society together?
I think the first thing that it does is it creates a platform of unity, of community. So science engagement, science communicate can be quite a lonely business when you're out there. And it's good to know that there's a group of people like you that are interested and passionate about it, swap stories, swap approaches, etc. And that's very positive. The danger is that then becomes an echo chamber of a small group of people reaching it. So we know from the empirical studies that actually a lot of public outreach and science outreach, science communication reaches a very small portion of the population, and they're already interested in science and already aware of these issues. The trick is, how do you break through to those broader audiences that aren't interested in it and might not be turning up on the platform? So I think these kind of platforms need to evolve to be more and more reaching out and thinking of innovative, creative ways to break down the traditional public academia barriers. But you need to start with a community, and you need to start with a platform. So it's fantastic.
Thank you so much, Professor. It was an absolute pleasure doing this Q&A with you, and I'm sure our attendees had a lovely time. We can have a look at all of the ISF recordings that go up on our YouTube channel. We'll be putting them up post the festival, and we're streaming all of our events live on YouTube, so you can check them out over there too. Professor Stewart, thank you so much for your time, and we'll be associated with you in the coming years too. And we would love to host you at a festival when it actually goes offline. Yeah. And we would love to host you in India for the same. But thank you for taking the time out, and it was absolutely lovely hosting you here. Thank you.
Thank you very much, and thank you for reaching out and giving me the time. Thank you.